Welcome to Brain Vision.
In this question, we have a string that is stretched, and this is 75 centimeter, and it is a resonance frequency F equals 420 Hertz, and then F equals 315 Hertz. And these two are constant resonance frequencies, but of course, they're not necessarily the lowest one. So we actually need to understand exactly which resonance frequency, like which end they correspond to. And how we're doing it is we can find the ratio of these two frequencies. So we can divide. So we can first express them as 2L over N, 2L over N. And then the frequency is F equals V over lambda equals NV over 2L. So all the frequencies are N times the lowest frequency. So so we can find the ratio of these two if we do 315 over 420. We can actually find that 315 over 420, we can find it's 20 over 28, which is 3 over 4. So they are the third lowest frequency and the fourth lowest frequency. But another way of solving it is that since they are adjacent frequencies, we know they must be, one must be Fn and one must be Fn plus 1. So for the difference between them, this must be Fn plus 1, this must be Fn. So if we look for the difference of frequency between them, the difference of frequency between them will be exactly equal to the lowest frequency. So if we do that, we find the lowest frequency is actually 105 Hertz. And then we check if it's 105 Hertz, again, this is n equals, this is n equals, and they are at frequencies. So our two methods actually, they both have the same answer. And then we look at the part B. Part B asks us to find the velocity of traveling. So for the frequency we have lambda. If it's lambda with length times is how we find. We can use lambda in every single mode. For any mode, it will give us a split. I will use the first mode, the frequency mode, just because it's easier. So for the lowest frequency, the lambda is 2 times L. So it's 2 times 75, 0.75 meter. The frequency is delta frequency is 105 Hertz. So it gives me 158 meters per second, and how fast waves can traverse wire.